Hello developers, welcome back to my channel. Have you ever had your front end send too many API requests while the user types? Let's fix that. In this video, I will walk you through a real-world React application showing you how to apply Debounce and Throttle and compare the behavior before and after. Let's dive in. Here is the simple React application, which is search box. Right now, every character I type sends a fetch request immediately. Let's say if I want to search for hello, and if we inspect the network, watch this. In the network request tab, you can see I fetching HEAL, HELL. That's 5 network requests for one user query. That's not good, especially a mobile device or when you're taking a rate limited API. Also, that's only one user. Just imagine for model application that potentially can have thousands of requests per second, and if just imagine that like 1/5 of the request is valid, so we have a lot of waste. And also these requests sent to the downstreams, the API search, and also the database fetches. Just imagine 1/5 of them are valid. That's a huge amount of waste for all the resources along the way. So how do we stop this? Let's start with debounce. Basically, debounce waits for user to stop typing before it sends the request. The key idea is only send the API call after, let's say, 500 millisecond pause. Here's the plan. So we will use the set timeout inside a use effect and store the timer with a reference. Each time when the query changes, we clean the previous timer and start a new one. This way, the request only goes out after typing stops for half a second. Let's edit the code. Currently, we have this search box component. We have a hook called use search, and inside it, it has a use effect. Whenever a query changes, it will check if the query is empty. If it's an empty one, we will set the result as empty and then return. And otherwise, we will fetch the result. If everything goes well, we set the result as data, and also we handle the error very simply here. So we will need to add a reference for the timer, and then we can see how the debounce works. So first, let's define a timer reference. We use a ref. Initially, it will be now, and we will import the ref here. And also inside the use effect, we'll check if timer exists. So this will happen when the query changes. We'll check if the timer is already there. We will clean the timer with timer the ref the current. We don't want that from here. And also we will then assign the timer ID to be set timeout. Simply put this fetch block inside this timer and give it a timeout like 500 milliseconds. Obviously the type is not correct, so we'll need to but here it's Node.js the timeout type, or it will be now. And then we will need to return a cleanup function as well, because it's inside the use effect. We will also check if the time reference is defined. If it does, we will clean the timeout when the component amount. And this way, it will only send request after the timeout. Let's see if it works. In a browser here, if I type hello, it only sends out the hello. If I type fast enough, let's say H, it's HE, and if I type fast, it only sends out when I stop typing. That's great. So if we try hello, and if I type like very fast. Nothing will be sent out until I stop. And then you can see the query is sent out like this. That's exactly what we're expecting. Now let's try Throttle instead. Throttle limits the frequency of a request. For example, once every second, even if the user keeps typing. It lets the first event through, then ignore others for a set time window. We will store the last call time within the reference as well, and use the data.now to check whether enough time has passed. Let's write the code. So in here, I will do a simple refactoring to extract this part into a function. So let's call it fetch result and give it a query, which is a string, and we will copy the whole fetch logic in here, and then we will call the fetch result like so. Just to do a simple refactoring here. All right. So we will need another reference, which is last called reference, and it will be a reference to last call time. It will be a 0. It should be a number, and every time when a query changes, we will check the time data the now. We'll get the data first, and then we say, and now we check now minus last called the current. I will give it a name to be elapsed. So we'll check if elapsed is greater than second, let's say. If it's already passed a second, we will fetch the result with the current query, and we will reset the last called the current to be now, right? So we will fetch query after a second since the last query change. Otherwise, we will define a timeout like so. So we'll do a timer inside here. Obviously we'll clean it in here as well. And in the timeout, we will reset the last called the current to be date now, because it will be in the future, like after some time. We'll give it a timeout here as well. It will be something like 1000 minus the time has elapsed. So if the elapsed time is less than 1 second, we will set a timeout. Obviously, we will need to clean it. If the time has already defined, we'll clean the timeout, and then we will start a new one after a certain period of time. And also, the cleanup will be there as well. I'll remove the black lines here. So now let's try it in the browser again. So now if I type hello, and if I keep typing, it will send out every 1 second if I type very fast even. And let's do that one more time. Hello. You can see as I keep typing, it's not sending every keystroke. It's only sent every 1 second if I keep typing. And if I don't type, it will not change anything. So if I type fast enough, like hello, it will skip the keystrokes in the middle. You will see a request go out immediately, then nothing for a second, even I keep typing. So that's the beauty of the throttle. This is useful when you want to keep things reactive, but not overload the system. Let's compare the three behaviors side by side. So if we don't have any optimization, every keystroke fires a request. So for Debounce, we wait until typing stops. then fire 1. And for throttle, fire 1 immediately, then block the rest of for a period of time, let's say a second. You would use debounce when you want to wait for a final input, like in search box, and use throttle when you want to update in near real time, but not too often, like on scrolling or resizing the window. In interviews, this kind of problem shows up often. It tests your understanding of async logic, performance, and user experience. Debounce and throttle are simple but powerful tools, and knowing when to use them is key. Bonus points if you can combine this with request cancellation or loading indicators. I have published videos on both these in before. Please have a look at it if you haven't yet. If you found this helpful, give it a like and subscribe. Drop a comment if you want to see another challenge, maybe retry with back of logic. Thanks for watching and see you in the next one.